Topic this evening will be dependency injection on iOS. I hope there is a lot of iOS developers here. Raise your hands. Yeah, cool, great. I'm very happy about it. My name is Maciej. This is my Twitter handle. Go and grab me. I'm really responsive. I work in a company that is called Polidea, or Polidea in Polish. Sounds better. And we are a software house. We build products for other people. And we do a lot of apps in one time. One engineer is involved in 2 or 3 or more projects in a year, so that is a lot of code to write. And that's why we struggle really hard to develop the best practices we can to build reasonably high quality products and with reasonable time, or in short time even. So I'm going to talk about dependency injection, because I believe that this is a pattern that leads to better software design, and for developers, for our company developers, it's a key pattern to control complex systems and complex applications that we have to build very often. So, 3 topics. First of all, why? Why should we care at all? I mean, is it so hard to understand it, or is it so easy even to talk about it? DIY, just do it yourself in your own products, and probably the most interesting part, frameworks. I will show you some code, so I hope that you will stay focused. And I know that some of you are interested in Swift, and I'm going to cover that as well. So, starting with dependency injection. I don't know how about you, but for me, this injection stuff is about syringes, vaccination, and it's a little bit ugly. So you may have some better ideas for this name. I mean, maybe dependency resolving, passing, or whatever. What I want to point out, I want to show you this hashtag, again, Twitter. I hope you may have some cool names other than dependency injection, or you may start cool discussion about it. It would be super cool. It will be visible all the time here. And I think that during this presentation, we'll stick to dependency injection. It is simple. All right, so let's start with testing, right? Tests will be our guide during this presentation. It would be this slide for us. So when we are going to talk about testing, we have to mention that probably we all here love TDD, right? Yeah, okay. almost everybody. However, if you don't like it, we probably are well educated, right? There were a lot of talks here. We've read a lot of blog posts about it. So, but we don't really often do TDD, right? We don't really know sometimes how to do it. We are like, oh my God, I'm going to write some tests, let's skip it. Or I don't have time for it, right? We have to build products fast. So, sorry, no tests, right? However, our product owners and management is being educated, right? It's getting better. However, the time is still the issue here. But there are more difficulties with testing, right? Tests made our code change. They made us to change our mind during development. And finally, TDD have influence on our software design, simply. And this is very good, because TDD is exactly for that. First of all, it has to prove that our code works and it behaves like we want to. And secondly, it has to ensure us that we control it and we have good patterns out there. And happy to tell that DI, so dependency injection, is a key pattern here when you're doing TDD. And that's very good because dependency injection comes with TDD. However, it does not depend on TDD. And that's really great. And this slide will be very, very quick if you are doing trust-driven development. So you don't write tests, you just trust that your code will work. Dependency injection will be there for you to develop fairly high-quality code. And just let's forget about it. All right. Why should we care about dependency injection? And I will talk with some examples. Let's do it quickly. I believe that will be probably very obvious for you that this part, this code, is not very good for mainly two reasons, or even three. First of all, when we would like to build, let's say, a music service, worldwide music service that serves the best music ever, and it's breakthrough service, right? It's a revolutionary service. We need some music advisor class, which needs album provider class, which has some dependencies. And what are the issues here? They are pretty obvious. First of all, those objects may be needed somewhere else. Second of all, looking at the interface of this class, we don't know what are the dependencies, and we don't know how the album provider is configured. And thirdly, we can't test this code. Easy. So this is rather sad code, but we can think a little bit and develop something like this. And we resolved one thing. We have these objects on properties, so we can pass them around. But really, this is an impression of on progress. This is not an improvement, because we still can't test this. Nothing has changed. We have still hard-coded dependencies, and even more, our music advisor has some redundant dependencies that he doesn't require. This is insane. This is really messy. So this is even worse. It makes us cry, probably. And the third example, this is my favorite example, about shared instance. I believe that many of you are familiar with this kind of stuff. And this is not bad because we assigned the shared instance to our album provider property, which is not really so bad because we can use this ivar or property in our class. But probably more often we see something like this. So we want the best soundtrack ever for our great music service, and we just use this in our method. And this kind of stuff is a ticking bomb. The shared instance is absolutely ugly and bad pattern. Why? Because first of all, you don't have clear interface of your class. Second of all, you don't have any control where your shared instance is created and how it's created, what are the dependencies of your shared instance. And this leads to really unpredictable design, and the bigger project grows, the less control over your app you have. This is absolutely ticking bomb, and this is a very professional term. It's called Dependency Explosion. This is a place when you laugh. Thanks. So what's the solution? Solution is brilliant, super simple, and this works for Objective-C and Swift and any language you probably know. We just inject our dependency through parameter. So probably this talk may end right now, but let's go on. Let's continue. In fact, we can do two ways. We can inject our property through initializer, or we can just assign it to a property. Which one do you think do you like most? First or second? First one. Yeah, great. Me too, actually. Let's say why. There are two main reasons. I think one of them is immutability. You probably may know the term. There were a lot of talks on Swift about it, but it ensures that our object won't change during its lifetime, and it's very good because it makes us feeling safe. And the second argument is that we have clear interface, and it's even more important because we exactly know what dependency is required for our music advisor to be working. And it's super important because when we have a property, it can be allowed, or it can change during our object's lifetime, and it will be awful when you use your object and you expect something and it has just changed. And you don't have this clear interface, you don't know if you may assign this property or not. What can really happen? We don't know. So initializer approach, we think it's better, right? And of course, our classes are easier to test if we do that. They are sometimes possible to test because, for example, testing shared instance is possible, but it's super ugly and it's definitely not elegant. We have our tight coupling removed, and what dependency injection promotes is composition over inheritance. We can do a much more composition, which is better for clarity and for reusability of our code. This is nice. Okay, so DIY. The first advice here is just do it yourself. And there are two strategies. The first one is super simple, just pass objects around, right? Just use it. Use the pattern, but be consequent about it. This is pretty obvious, but this is pretty good. The consequent, but you have to be consequent. The second advice is to develop your own framework, your own dependency container, or let's call it application context. And let's dive into this strategy because this is it's a little bit more interesting. And of course, this code applies to Objective-C and Swift. You can easily develop your application application context with Swift. So, how may it look like? I would like my application context to look like this. I want just to call root vController, and that's all. I don't want to care about its configuration, creation process, or stuff like that. I just want to use it. I want it to be elegant, nice, clear, and one-liner. How may we build it? Let's focus on the second method. Here we have just simple creation of this object. We use data source because we are smart and good engineers. So here is data source, which may even require some HTTP client. It will be more complex, right? And basically that's all. Super simple. Configuration is in one place, easy to understand, easy to write. There is one line that may require a comment. And this is assigning our app context to the property of this vController. Why this is nice? Because our albums vController, as you see here, is probably a list of albums. And after tapping on our list of albums, we may want to see album details, right? So when I select my item, I just want to ask my application context for proper vController. I don't want to care about its dependencies, about additional music player that is going to be there to play this album and everything. I just want to get this controller and present it. So passing application context is a really nice solution and simple to start. Of course, it has some limited behavior. What about cycles? What about circular dependencies? What about storyboards if you use it? What about configuration files? There are a lot of functionality that it doesn't cover. But in general, it's a good start. For sure, if you're starting maybe your project in Swift, it's a great way to start because Swift doesn't have rich runtime, so creating objects like in Objective-C may be much, much harder. And now let's go to frameworks. I'm going to talk about two frameworks that I'm familiar with, that I have selected to talk about. I think that they are the best frameworks available in the open source world. First is Objection, and the second one is Typhoon. And my question to you, do you have any experience with those frameworks? Any of them? Anyone? All right, great. So let's start with Objection. This one is almost 4-year project. So it's pretty mature right now. It's really stable. But what is unfortunate, it's not longer developed, as far as I know. So you won't find any version for Swift, unfortunately. But in general, it's very nice. It's lightweight. It's almost like you would write your own framework, dependency container framework. And the key here is annotation-based dependency injection. I will explain it just in a minute. But for sure, with Objection, you get everything you need, you would expect from any framework that injects some dependencies. So let's move to key concepts. There is injector and there's module. And how would I use it in my code? So as you see, we stick to our music advisor. Let's imagine that we have this property album provider, and we want to use it. We want to inject it with our great framework. So what we have to use is a macro. In general, Objection provides you a set of macros, very different, and this is one of them. You just say you require selector. There is a runtime magic underneath. It just knows that thanks to that, it can find this property and inspect it and just inject it afterwards. And there are two things that we need to talk that has to be said about this code. First of all, when you're injecting properties, you won't have access to those properties in your initializer. So Objection provides you a wake from objection method that is called right after injections. So you can do all setup of your class here. And second of all, Objection in general trusts developer, because if you are focused, you will notice that this is read-only property. So it shouldn't be able to assign it, right? Because it's read-only. However, Objective-C runtime is just very, I mean, it doesn't care about read-only properties and annotations, so you can basically do everything with Objective-C runtime. And this is a piece of cake to inject this property here. So Objection just trusts that you know what you do as a developer. And the usage is super simple. You just create an injector, you just get an object of desired class. What you need to know is that the Objection uses a default initializer, which is init, right? And we're moving to modules. This is the second key concept here. This is a little bit more advanced code. So module is a really detailed configuration for your injector. So that injector has additional information of how to create your dependencies, how to manage them. Basically what you have to do, just subclass the Objection module and override configure method. And what you can do, for example, you can bind class to protocol. If you have your property and it's a property, it's a protocol property, you can say that this property should hold an instance of this class. Pretty easy and pretty flexible and useful. And then you can use some providers, your own blocks. Even you can say that you want to have this class like singleton scoped, so only one in the context of your injector. So this is pretty nice, and you have your configuration in one place. And the usage is pretty simple as well. Just create an injector with your module and get the class just like before. So why would you like to try it? First of all, it's pretty simple, pretty lightweight. It's easy to understand. It has maybe up to 10 classes, so it's really easy to follow what's the stock trace, and pretty flexible. I have used it in, I believe, 2 quite big projects, and I was really happy about it. Why would you not like it? Well, sometimes simplicity is not the best thing. We need something more advanced. It's not Swift friendly, as I said, and it promotes property injection. We said at the beginning that we probably all like the initializer approach better, right? More. But Objection really promotes property injections, because when you're doing property injection here, Objection does magic. I mean, it just worked like a charm. However, if you do initializer injection, it boils down to really manual injection. Nothing changes. So this is not a good thing here. And it's invasive. You probably noticed that we had to put our objection, it requires selector macro inside the source code of our class. Not everybody likes it. So it's invasive. You have to add additional code to your classes. Okay, so let's go to Typhoon, the second one. This project has 2 years, so it is a younger brother. Not really a brother, but it is under really strong development all the time. Recently, the 3rd version was released, and it's pretty great. And they have excellent support, really. You will find issues on Stack Overflow. They have even Git channel for that, for all the contributors and people that are willing to contribute or they have some trouble or in trouble. So pretty cool. And this is rather more advanced framework than Objection. So you may expect all Objection's features. But for example, if you do your apps using storyboards, you will have storyboard integration. If your object graph is quite complex, you may expect circle dependency support as well, which is nice. If you are insane, you will have Swift support. So yeah, this is nice. And the key concepts here are assembly and definitions. And let's go quickly through it. And Typhoon is basically pretty complex, so even this part of the code will require some explanation. So let's quickly dive into it. To configure your container, you have to subclass an assembly, just like here, music assembly. And what you see here is code in Swift, in Swift 1.2. There is an album provider function method, so we can expect that this method should return album provider. But as you see, the return type here is not album provider. And even more, what is returned here is Typhoon definition with class. So how does it work? Because it just doesn't make sense here. There is a lot of runtime underneath. Basically, Typhoon, what it does on the application startup, it searches through all assemblies and finds all methods that you have provided here, invokes them, so all definitions are being created. And definitions are simple scenarios of how to build your objects finally. And then there's methods swizzling. And at the runtime, when you're using this method, you may expect not a definition object, but really album provider object. This would be a little bit more clear in Objective-C, because in Objective-C, this is a valid code to put here album provider class here. But in Swift, we have really strong type safety, so we can't say here album provider and return definition. Just impossible, right? So we have to put here any object. It may seem a little bit complex, but don't worry. How would you use it? You could create assembly, activate it. This is when all the magic happens. So your methods are being invoked, definitions are being built, and methods are being swizzled. Then you just call your album provider, and you have to cast it, because this is any object underneath, right? All right. This is the same example here. And this is advanced example for definition, because the definition is this receipt, this scenario of how your object really has to be built. So definition, you may say that in definition you use init with album provider. So this is our initializing method. You can say that you want to inject it. You can say you need a soundtrack composer as a property, because property injection is possible as well. And you can say that you want assembly itself. You can, of course, scope it and do a lot of stuff other than here. This is really powerful, and the usage is just like before. You just call Music Advisor and cast it. Really simple. Advanced usage. And I promise this is the most advanced piece of code today. I hope you see it quite well. What else can you do with Typhoon? First of all, the first line here, as you see, we have themes assembly. So we can split our configurations into different assemblies to make our design a little bit more clear and divide it when the divide on functionalities. Here we create Music Advisor just like before, but we want to have this album provider from the outer scope. So we say we use this initializer with album provider and themes composer. We get album provider from the outer scope during runtime, and we take default composer from our themes assembly. This is very nice. Moreover, we can say we can specify special method appdelegate when we can configure our appdelegate method, and it will be configured during launch time of our application. And this is really clear and nice because when we use our appdelegate, we have those properties already injected and configured. So we just simply can assign a read view controller, use our Music Advisor, do something with assemblies, and it's very elegant. So I believe that it may seem to you a little bit overwhelming, right? The syntax is not very nice, a lot of blocks. Believe me that in Objective-C it is even worse. Block syntax is really suck there. So it may seem a little bit overwhelming. It may seem a little bit complex as well. So it has quite a steep learning curve, unfortunately. But once you understand it and get it, it's really powerful, and it's really nice when you're using it. And I really do like Typhoon right now, even more than Objection, because it's really configurable. It promotes initializer approach. It's non-invasive. You don't have to put any additional code inside your classes. You can just get rid of your framework, of the Typhoon framework, and you're still working. It supports testing very nicely. It has some additional objects and methods that you can use during testing, and it supports Swift if you need it. So, to recap, dependency injection in general is a very powerful pattern. You can use it at any time in any language, but in Objective-C and on iOS especially, and consider it. It's quite easy, so probably the learning curve is not really steep here, but let's start with building your own lightweight frameworks. Maybe you will come up with something better than Objection and Typhoon. And of course, there are frameworks to help you. I hope that I have given you a pretty nice and easy overview. So if you have any questions, you can catch up me here. Please write under this hashtag. We can discuss a lot on Twitter. And that would be everything. And thanks for your presence.
If you use the separate framework for dependency injection, you are giving up some control over your code, over how your objects are created, the objects that you use are created, what is their lifetime, and so on. So you are prone to bugs coming from the framework. How do you feel about losing that control, which is like quite essential, because if something is not in the initialized in the runtime, the app just crashes.
Well, I feel okay. Before using any framework, any external third-party framework, I read the code and I try to understand it. I try to see if it's well tested, and I try to count the GitHub stars and how many people are using it and all this stuff. So basically, I think that we all do it, but on the little bit minor scale, right? If you use some date framework or testing framework, we do rely on it, right? Still, if you're using, for example, Kiwi, right? You rely on it, and your tests rely on it. So this is as well pretty important. Actually, after some time that I have an experience, for example, with Objection and Typhoon, I sleep well, really. I don't see any disadvantages of those solutions. The performance is pretty great. Usually you don't have to care about it, because if you have performance issues, it's usually your fault, not framework's fault, right? So this is totally fine. This is totally fine.